Hi, so we're going to be solving paper 9702, October, November 2017, paper 22. Okay, so question 1. One end of a wire is connected to a fixed point. A load is stretched to the other end so that the wire hangs vertically. The diameter D of the wire and the load F are measured as. This has been given to you and the error is also given. With the measurement of the diameter of wire, state the name of suitable measuring instrument. So that would be a micrometer, screw gauge, right? Why would it be micrometer screw gauge? Because the diameter is given in 0.02 millimeter, and anything, because it can be used to measure anything that is less than 1 centimeter. How random errors may be reduced when using the instrument in one. So how can you reduce a random error when using micrometer screw gauge? You can for sure take several readings along the length of the wire and take average. Wait a second. Take several readings. So this is it. The stress in the wire is calculated using the expression. Show that the value of stress is 1.99 into 10 raised to the power 8 nano per meter square. So how can you do this is firstly just take the values given above in the question and plug them in, right? So you're going to write for F is given as 25, while J is given as 0.4 millimeter. So here take note that we have to take, we have to take this in meters and not millimeters, so remember to convert it. So 25 over pi, we have to convert 0.4 millimeter into meters. So 1 meter is equals to 1000 millimeters. So what would be 0.4 millimeter? So you just have to divide. So I'm going to write here 0.4 divided by 1000, the whole square, just as this expression. And when you will calculate, you'll get the answer of 1.99 raised to the power 8. Right, so let's move on. Determine the percentage uncertainty in stress. For percentage uncertainty, you need to have a look at the errors that are given. 0.02 millimeters and 0.4 and 0.5 and 25. Okay, so let us write for F first. There is an error of 0.5 over the total value, that is 25, into 100 since we are finding out the percentage. And then plus, because errors always add, these are the uncertainties, so you need to add them. Now take note of this power of 2, you need to include it here. Powers will always come ahead and you multiply them. 0.02 over 0.04, sorry, not 0.04, just 0.4 into 100. So calculating this would give you an answer of 12%. Okay, make sure to write your answers in these spaces. I'm not writing them right now, but you should write them. Use the information in B1 and your answer in B2 to determine the value of a stress with its absolute uncertainty to an appropriate number of significant figures. Now you need to take note when you're giving your answer of the absolute value and absolute certainty. You need to be giving the correct number of significant figures and decimal places. So let's start with this value that we found out in our part 1. It is this value of stress. So we need to convert this to one significant figure. Then it would become 2.0 into 10 to the power 8. I hope you know how to convert this to the appropriate number of significant figures. since we give our error in one significant figure, we are going to give the value in one significant figure too. Let us write it here. Now we need to find our absolute uncertainty. For that, you need to take the percentage that you found out in part 2, that is 12%. Now you always divide percentages by 100, and then you're going to multiply it by the value of 1.99 into 10 to the power 8 to find out your absolute uncertainty, which is coming out to be something like this. Now you need to convert this in one significant figure and also write it in standard form. So how it would be done? Let us count this. 1, 2, 3, 4, 5, 6, 7. Right, 7. 2.4 into 10 to the power 7. Now you need to make sure that these powers on your tens are the same, but here they're not the same. So we're going to convert this to 0.24 into 10 to the power 8, but here the significant figures are 2, so we are just going to write 0.2 into 10 to the power 8. Let's move on. Okay, so to find the moment of force. So remember this formula of moment, F into D. So what was F? Moment is basically a product of force and perpendicular distance about a pivot in the line of action of force. Right? A thin disk of radius r is supported at its center O by a pin. The disk is supported so that it is vertical. Three forces act in the plane of the disk, as shown in figure 2.1. Two horizontal and two and opposite forces, each of magnitude 1.2 newtons, act at points A and B. Here you can see that. Sorry. And edge of the disk. Okay, so edge on the disk. Oh, on the edge of the disk, right? Here and here. Okay. A force of 6 Newton at an angle theta below the horizontal acts on the midpoint C of a radial line of the disk, as shown in figure. The disk has negligible weight and is in equilibrium. State an expression in terms of R for the torque of the couple due to the forces at A and B acting on the disk. Couple is what? Couple are two forces that have same magnitude and they are acting in opposite directions, just like here. And if they're acting in opposite directions, then we are going to add them, right? So let us see. For example, we take this pivot and we see this force 1.2 newtons, and the distance, perpendicular distance from the pivot is this perpendicular distance. This is r, and same is the case with this one here, right? So we are just going to pass them into r plus 1.2 into r, which would give us 1.2, 1.2, 2.4 r. Friction between the disk and the pin is negligible. Determine angle theta. For this, you need to write this expression, this equation, that clockwise moment is equals to anti-clockwise moment, but about the same pivot, of course. So clockwise moment, let's see the diagram. So this A and B, these are going to produce a clockwise moment, while this force here is going to produce an anti-clockwise moment. So let us write in clockwise moment, simply this expression will come 2.4r is equals to, let us see, this force right here is 6.5 distance from this pivot. So we are going to take this 6 into this distance and sine theta. Why sine theta? Because we are finding this component, right? Anti-clockwise moment. So this is theta and this is, if we take sine, then sine is opposite over hypotenuse, right? So we are taking opposite here, and hypotenuse is our 6 into r upon 2. So sine theta Now these are going to be cancelled out. This is going to be cancelled out. This becomes 3. You shift this 3 here, and then you are going to get a final answer, not final, just a fraction, 4.5, and then you shift the sign, take the sign inverse, like this, and the final answer you're going to get is 53.1. You can just write 53, it's up to you. State the magnitude of the force of the pin on the disc. So you see here that this is the force that the pin is exerting on the disc. Okay. A spring is attached at one end to a fixed point and hangs vertically with a cube attached to the other end. The cube is initially held so that the spring has 0 extension, as shown in figure 3.1. Okay, cube has a weight and sides of length. Okay, the cube is released and sinks into the water as the spring extends. The cube reaches equilibrium with its base at a depth of 7.0 centimeter below the water surface. The density of water is given. Calculate the difference in the pressure exerted by the water on the bottom face and on the top face of the cube. You can simply do this by finding out the difference in the pressures. So let's try to make an equation first. Difference in pressure is given by density G and difference in height, right? So height first, you basically write this. Now you're going to make an equation, which is the density is 1000 and G's value is also a constant. And first we are going to take for the base. So this is given to us till the base. This is the base here. So it is 7 centimeters. Convert centimeters into meters by dividing it by 100. And you are going to subtract the pressure on the top face from this pressure on the bottom face. Bottom face, and this is for the top face. 81 into, now let's see here, the top, what would be the depth from the top? If the hole is 7 and the side of the cube is 5.1, so we are going to subtract 7 minus 5.1 will give us 1.9. 1.9 divided by 100 to convert it into meters. Now doing this calculation you will get the answer of 500. Use your answer in A to show that the upthrust on the cube is 1.3 newtons. So upthrust is given by change in pressure into cross-sectional area. So change in pressure is 500 into cross-sectional area is 5.1 square, but converted into meters, and the answer would be 1.3 newtons. Calculate the force exerted on the spring by the cube when it is in equilibrium in the water. So force would be given to us by subtracting upthrust from weight, right? Since the object is in equilibrium, there is a weight acting. Sorry, let me do it on this diagram. There is a weight acting, and then there's an upthrust and another force on the spring, right? So these all forces would give us a 0 when we are going to add them. So for now, to find the force on the spring, we can just subtract upthrust from weight, right? So weight is given to us as 4, and upthrust we just found out that is 1.3, and the answer is 2.7. So the sum of upthrust and the force on the spring would give us the, when added, would give us the weight, right? And that is telling us that the object is in equilibrium. The spring obeys Hooke's law and has a spring constant 30 Newton per meter. Determine the initial height above the water surface of the base of the cube before it was released. Let us first write the formula of Hooke's law, which is F is equals to KE, where K is the spring constant that is given, and force is 2.7 that we found out. So 2.7, 30, and we're going to find out the extension, right? So extension will be 0.09 meters. Let's convert it into centimeters, since the answer we have to give here is in centimeters. That will become 9 centimeters. Now let us go back to the diagram. Here, this distance here is covered. This whole distance is 0.09. This was extension, right? And this underwater distance is given, which is 7 centimeters. So to find out this distance above, we just have to minus 7 from 9, right? So 9 minus 7 would give us 2 centimeters. The cube in the water is released from the spring. Determine the initial acceleration of the cube. So resultant force is equals to mass into acceleration. Resultant force would be given again through subtracting upthrust from weight. So 4 minus 1.3. Mass is not given, but weight is given, so you're just going to divide the weight with 0.81 by this formula. Weight is equals to mg, where weight is 4, mass is not given, g is 9.81, and you have to find out acceleration. And after the calculation, you're going to get the answer of 6.6. Describe and explain the variation, if any, of the acceleration of the cube as it sinks in the water. Now, think of it in the same way when a parachutist jumps from a plane and opens his parachute, and at some point he or she gains terminal velocity. Think of this object in the same way. So as it will go down, viscous force increases. Just as air resistance increases in air, viscous force will increase in water, and then it will become a constant at some point. Constant, right? Weight and upthrust will remain constant no matter what height the object is covering or depth. Weight and upthrust are going to remain the same. Remains constant no matter how deep the object goes. So acceleration decreases to 0 with time. So acceleration decreases to 0 with time. State the conditions required for the formation of a stationary wave. You need to memorize this. Two waves traveling at the same speed in opposite direction overlap. These waves should be of same type and same frequency and wavelength. A horizontal string is attached between two fixed points, x and y. This string is made to vibrate vertically so that a stationary wave is formed. At one instant, each particle of the string is at its maximum displacement. P and Q are two particles of the string. The string vibrates with a frequency of 40 Hz. Distance xy is 2 meters. State the number of antinodes in the stationary wave. So 1, 2, 3. This is antinode. This is antinode. This is antinode. This is antinode, and this is antinode. So these are 5 antinodes. Determine the minimum time taken for the particle P to travel from its lowest point to its highest point. So meaning from here to here. Time taken from here to here is what? It is half a period. Period is the time taken for a complete oscillation. This is only half of the oscillation. A complete oscillation would look like from this point to highest point and then again back to this point. But here they're only asking for half a period. So minimum time taken would be, we have been given the frequency, let's use that to find period. So period is equals to 1 over frequency, 1 upon 40 would give us 0.025 seconds. And we just found that we are taking the half of the period. So let us divide this by 2. And the answer would be 0.0125. We are going to write it in standard form. Okay. State the phase difference with its unit between vibration of particle P and of particle Q. So notice that there is a node between, this is a node between particle Q and P, due to which they are out of phase. Whenever there is a node in between two particles, they are considered to be out of phase. And the phase difference when the particles are out of phase is always 180 degrees. Determine the speed of a progressive wave along the string. This is very easy. You can use the formula v is equals to f lambda, where f is given to you as 40, while lambda you can find out from the diagram. So the whole, how many waves are these? Let us count. So this is 1 here, second, and half a wave. So this is 2.5 waves. So you know that if for 2.5 wave the length is 2 meters, then how much for 1 wave? So you just need to divide to get the answer. Divide 2 by 2.5 to get the wavelength, and it will come out to be 0.8. And after doing the calculation, the answer is 32. I am skipping question 5 because it is from electric fields chapter, which is not a part of AS level physics syllabus anymore. So let's move on to question 6. State what is meant by an electric current. An electric current is the flow of charge carriers. You need to memorize this. As moving on, a metal wire has length L and cross-sectional area A as shown in figure 6.1. I is the current in the wire, N is the number of free electrons per unit volume in the wire, V is the average drift speed of a free electron, and E is the charge on an electron. State in terms of A, E, L, and N an expression for the total charge of free electrons in the wire. Okay, so for total charge of free electrons, you obviously need to have the number of charges, right? And then you need to know the volume of the wire, right? And volume of the wire could be L and L length, and A, which is the cross-sectional area. This gives you the volume of the wire. And lastly, you need to have the you have to put in the charge on a single electron. So E. So simply you are going to write N, A, L, which is the length, and E. Use your answer in one to show that current I is given by equation this. So you need to derive this equation. How you can do that is, firstly, we know that current is equals to charge upon time, right? So using this, we know that the charge, this total charge is this, right? So this becomes N, A, or you can say number, cross-section area, length, charge on a single electron upon time. Now, let's just see this, compare this equation to this. What do we need to have or remove in order to get this one here? So there is one thing here that we can see is the drift speed, right? Drift speed right here. So let's just see what's a general formula of the speed. Speed is equals to distance upon time. Let's see if these things are in this equation or not. So here length is sort of a distance and time is here, so we can simply substitute this whole thing with drift velocity. So that becomes what? Current is equals to number of electrons, cross-sectional area, drift velocity, and the charge on a single electron. So here our equation is derived. Okay. A metal wire in a circuit is damaged. The resistivity of the metal is unchanged, but the cross-sectional area of wire is reduced over a length of 3.0 mm as shown. The wire has diameter d at cross-section x and diameter 0.69 d at cross-section y. The current in the wire is given. Determine the ratio average drift speed of free electrons at cross-section y and at cross-section x. So we know that this formula that we derived before, NAVQ, and we know that drift speed would become the subject of the formula, which would give us NAQ. We can actually reduce this formula to just one concept, because we know that in each of the wire I will remain the same number also, and the charge on a single electron will also remain the same. Only the cross-sectional area is different for both of the for the damaged part of the wire and the normal part of the wire. So we can say that drift speed is equals to 1 over a if we remove all these three quantities, because they are constant for both parts of the wire. So we're just left with drift speed is equals to 1 over a. Now what we can say is area, the sectional area or area of y over area. But we have seen here that drift speed is equal to 1 over area. So for y, we are going to take 1 over pi. You do not even need to write pi because it is going to get cancelled. So for y, we saw it's 0.69 and it's a diameter, right? I mean, it's the, yes, it's the diameter. So we need to divide 0.69 d over 2 to get the radius square, over, again for x, 1 over pi, and for x, what was the, it's just d, so it's d over 2 square. Let me erase for some space right here. I'm continuing this here. So just do this calculation. You know that these things are going to be cancelled out. So let me write this simplified form here. So this part right here is giving us 8.4, and this part is giving us 4. So 8.4 divided by 4 is 2.1. Let me erase this all. The answer is 2.1. The main part of wire with cross-section X has a resistance per unit length of this. For the damaged length of wire, calculate the resistance per unit length. So this is the formula of resistance, where this is resistance, this is resistivity, length, and area, right? So you need to arrange this, and for resistance per unit length, meaning resistance over length, and resistivity over cross-sectional area. Now what does this shows us? Like resistance over length is proportional to inverse of cross-sectional area, right? So we simply need to multiply this given resistance per unit length, 1.7 into 10 to the power minus 2, with this ratio that we got of 1 over cross-sectional area, right? So 2.1. And the answer that is coming out to be 0.0357. You can write it in standard form. It's just going to be 3.6 into 10 to the power minus 2. Now you need to find the power dissipated in x, right? No, sorry, in y, the damaged length, y. So power dissipated in y, what you can use is you can use formula power is equals to I square R. This R can be calculated through this answer found in the first part. Since this is resistivity, you can use it 3.6 into 10 to the power minus 2 into the length, which is 3.0. It is in millimeters, so you need to convert it to meters. You can divide it by 1000. So this would give you resistance, which is coming out to be 1.071 to 10 to the power minus 4. Right. Current is given to us as 0.5. Square it and multiply it by 1.0171 to 10 to the power minus 4. And the answer is 2.7 into 10 to the power minus 5. Okay, the diameter of the damaged length of the wire is further decreased. Assume that the current in wire remains constant. State and explain qualitatively the change, if any, to the power dissipated in the damaged length of the wire. So we know that cross-sectional area is decreased. Area decreases. So what will happen? Resistance increases, because we know from this formula, resistance is inversely proportional to cross-sectional area. If resistance increases, cross-sectional if cross-sectional area is decreased, resistance increases, right? So cross-sectional area here is decreasing, so resistance increases, and hence power will also power dissipated also increases by this formula. Power is equals to I square R. A stationary nucleus decays by emitting a B positive particle to form a nucleus of carbon 13. An incomplete equation to represent this decay is, state the name of class group of particles that includes, okay, so it is going to be leptons. For nucleus X, state the number of protons. Okay, so we know that in the emission of beta positive particle, what happens to the proton number here? It gets one is subtracted from the original proton number. So hence we know that protons would be 7, and we know this 13 right here is the nucleon number which remains, which is restored, it doesn't change. So neutrons is going to be 13 minus 7, which gives us 6. Carbon 13 nucleus has mass. Its kinetic energy as a result of decay process is this. Calculate the speed of this nucleus. So we need to first do some multiplication with this given kinetic energy. This m represents what? 10 to the power 6. You need to memorize prefixes and stuff, and multiply 10 to the power 6 for mega, and for E this represents the charge of a single electron, which is 1.6 into 10 to the power negative 19. Right, so this gives us the answer of 1.28 into 10 to the power negative 13. We need to find speed, so let's arrange the formula of kinetic energy. Half mv square, v would be 2ke upon mass and the whole under root. So under root 2 into 1.28 into 10 to the power minus 13 over mass is given. Just need to plug in the values, and the answer, final answer is 3.4 10 to the power 6 meter per second. Explain why the sum of kinetic energies of carbon 13 nucleus and beta positive particle cannot be equal to total energy released by the decay process. So we need to remember during this decay, an electron neutrino is also produced, right? So it also has energy. So obviously only beta positive particle and the carbon 13 nucleus would not be the only energies. So an electron neutrino is also produced, and this has energy. For more clarification, this is the general equation of decay. memorize this. That's it for this paper. I'll see you in the next video.